You know, today we're going to talk about a language, but not when you speak. This is a language so fundamental, it's literally the foundation for our entire digital world, from the calculator on your phone to the most powerful AI you can imagine. This is the story of binary. So, what if I told you that every single image you scroll past, every video you watch, yup, and every word in every article you read, and even those incredible conversations you have with an AI, what if all that complexity, all that intelligence could be boiled down to just two little symbols? I mean, it sounds kind of impossible, right? Well, it's not. It all comes down to this: a 0 and a 1. That's it. And this is the story of how these two simple digits built the entire modern world. So, why these two? Why 0 and 1? Well, to get that, we've got to go back in time, back to a huge problem engineers were wrestling with long before we had anything that looked like a modern computer. And this quote right here, it just nails the problem. The real world is messy. It's full of nuance and gray areas. But a machine, a physical thing made of wires and switches, it just can't be. It needs a language that is brutally, absolutely simple, no confusion. A machine can't understand poetry, but it sure can understand if a switch is on or off. And you have to understand, this wasn't just some clever idea someone had. The choice to use binary wasn't random at all. It was basically a direct consequence of how the physical world works. You could even say the laws of physics demanded it. I mean, think about it at the most basic level. A machine can only reliably understand two states. Is there electricity flowing through this wire? Yes or no? Is the switch on or is it off? It's a clean, clear two-state system, and that incredible simplicity is its greatest strength. If we zoom way, way in, down to the level of a single electron, a 1 just means, hey, there's an electron here. And 0 means, nope, it's absent. There's no maybe, there's no kinda, and it's this absolute clarity that makes our computers so unbelievably reliable and fast. So, here's the key takeaway. Binary wasn't just a smart choice. For all practical purposes, it was the only choice. It was the native language that the hardware could speak, all because of the basic rules of physics. Now, for a while, this on-off idea was used in some pretty specialized machines. But then, in the middle of the 20th century, this brilliant guy, John von Neumann, came along and basically wrote the blueprint for almost every single computer we use today. And this was the real game changer. His idea, the von Neumann architecture, said that a computer's memory could hold both the stuff it was working on, the data, and the instructions telling it what to do with that data. And the key was, everything, the data and the instructions, would be encoded in binary. This is what turned a machine from a glorified calculator into a universal, programmable powerhouse. Okay, so we've got this language of zeros and ones. That's great, but how in the world do you get from a simple on-off switch to running something as complex as your favorite app? How do you create order out of all that digital chaos? Well, the answer is logic. This is where binary stops being just about on and off and starts being about making decisions. Tiny little circuits called logic gates, you might have heard of them and or not, they perform super basic logical operations on our zeros and ones. By stringing together millions or billions of these, every line of code you write is basically just asking a long series of tiny true or false questions. And just like that, a machine made of simple switches starts to think logically. So now we have logic. But how do we use that to handle enormous amounts of information? We need some kind of structure. And one of the most elegant, most beautiful structures is called the binary tree. It takes that core idea, two choices, and uses it to organize information. Every point or node can branch out into at most two more, a left path and a right path. And this really shows you the power of keeping things simple. Imagine trying to find one specific piece of information in a library with a billion books. That sounds impossible. But a binary structure turns that impossible task into just a series of simple choices. At every single step, the only question is, do I go left or do I go right? It makes unimaginable complexity totally manageable, and it makes finding things lightning fast. And this amazing ability to organize and search huge amounts of data with simple yes or no logic, it's not just for old school databases. It is the absolute bedrock of the most exciting thing happening in technology right now, artificial intelligence. Because when you look under the hood of AI, you'll find our old friends 0 and 1 doing all the heavy lifting. Just think about a basic machine learning model. What's it doing at its core? So often, it's making a simple binary choice. It's asking a question. Is this email spam? Yes, which we'll call 1. Or no, which we'll call 0. Is that a picture of a cat? Yes, 1. Or no, 0. Even the most advanced AI you can think of often starts with these super fundamental binary decisions. But you might be thinking, hold on a second. Modern AI doesn't just give me a yes or no. It gives me probabilities, like there's a 92% chance this email is spam. That's not a 0 or a 1. And you're absolutely right. The output is way more nuanced now. But the story doesn't end there. Because what happens next? The system has a cutoff point, a threshold. It has a rule that says something like, okay, if the probability is over 80%, then we're calling it spam. So that 0.92 probability, it ultimately gets boiled down to one final binary decision, spam. The label is 1. See? Binary never really went away. It just got a whole lot more sophisticated. And that's the most important thing to remember about all of this. AI is not magic. It's what happens when you apply incredibly simple binary logic, billions and billions of times per second, across enormous mountains of data. It's the sheer scale of it all that creates what looks like intelligence. You know, when you take a step back and really look at the whole journey, from a single electron zipping around to a machine that can write a poem, it's pretty profound. The story of binary actually teaches us something really deep about how we build and understand our world. This is the lesson right here. If you want to build something as ridiculously intricate as an artificial mind, you have to start with the simplest possible foundation: 2 states. An electron is either there or it isn't. A switch is on or it's off. And from that one single, simple distinction, our entire digital reality has been built. So the next time you see a breathtaking image or read a brilliant article or chat with an AI, just take a second to remember the 2 silent partners that made it all possible: 0 and 1. Because binary isn't just the language of computers, it has become the fundamental language of modern intelligence itself.